Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
Today we are going to discuss star to delta and delta to star transformation. Now, how do they exactly look like? We'll see that first. Now, this is how they look like. So basically, this type of connection is known as star connection, and this type of connection is known as delta connection. Fine. So delta, not always delta looks like a triangle. Basically, it's a closed loop kind of thing. Fine. Now, if we talk about star connection, only one end of three resistors are connected together. Fine. Only see, you can see that one end is connected. And if we talk about delta connection, one end of each resistor is connected together, and lastly the another end of first resistor is connected to the second end of the third resistor, so they form a closed loop. Okay, so first we'll understand how to convert delta into star. Now I'll tell you a trick for this. Now if you see, there are 3 points here. So there is a point number 1, there's a point number 1, point number 2 and point number 3. Similarly, we have R1, R2 and R3. So let us first start with R1. Okay, so which two resistors are connected with point number 1? It is RB and RC, right? So R1 can be calculated by taking the product of those two resistances. So it is RB into RC, and you have to divide that product by the sum of all three resistances, RA plus RB plus RC. Okay, fine. Now let us understand how will we calculate R2. Now what points, rather I would say which resistors are connected with point 2? It is RC and RA. So your R2 will be product of these two divided by the sum of all resistances. So it is RA/RC upon RA plus RB plus RC. Fine. Similarly, when you have point 3, RB and RA are connected. So your R3 will be RA/RB upon RA plus RB plus RC. Understood? Now let us understand the reverse way. How a star is connected to delta. Fine. So for this also there is a trick. Okay. So point number A will correspond to 1. Fine. Now here all the resistances are multiplied. I mean, one resistor is multiplied with second resistor in a cyclic fashion, like R1, R2, R2, R3, R3, R1. Okay. Sorry, you have to take the algebraic sum of these products and you have to divide by this corresponding resistance. Fine. I'll explain it again. Now suppose I have to calculate what would be my RA. Now A corresponds to point number 1. Fine. So what I will do is I will multiply all these resistors. Okay. So how to multiply it? We have to multiply it like R1 R2 plus R2 R3 plus R3 R1. And since A corresponds to 1, you have to divide this whole by R1. Okay. Now if you closely see, this R1 is common in two places. See this. So basically what happens to RA? Your RA becomes R2 plus R3, right, plus R2 R3 upon R1. Now this is the final equation, whereas this is the standard way of writing this. Okay, so you have to remember the standard way also, and you have to remember this shortcut also. Now again I would tell you that, see, RA has to be calculated. So you have to add the other two resistances plus the multiplication of that divided by the third resistor. Okay, now I'll again write it for something else and then you will understand. I hope now you understood how to write this equation. I'll tell you the final equation. Let us write the equation for RB. Now B corresponds to 2. Fine. So we will not write anything with 2. We will write it with 1 and 3. It means my total resistance would be R1 plus R3 plus R1 R3 upon the remaining one, which is R2. Fine. Similarly, I will write RC. Where is point C? Here point C. Here is point C and here is point 3. Correct? So RC would be R1 plus R2 plus R1 R2 upon R3. Fine. I hope you understood. You have to remember these equations always, because later we are going to use these equations to simplify the circuits. Okay. So our first numerical is that you have to find the equivalent resistance between point 1 and 2. So here you have 2 delta connections. Fine. So one delta connection is this. Okay. And another delta connection is this. So now it depends on you which you want to convert. Okay. I will take this one. So first let us convert this 4 ohms, 2 ohms and 6 ohms connected together in delta fashion, which will get converted in this way. Fine. So this was 4, 2 and 6. Now I have to first calculate R1. How will I calculate R1? I have to multiply the opposite resistances. So R1 will be given by 4 into 2 upon the algebraic sum of all the resistances, which is this. So this comes out to be 8 upon 12, right? So this is 2 by 3. So that comes out to be 0.67 ohms. So my R1 is 0.67 ohms. Okay. Fine. So now I will calculate what is R2. So R2 will be again multiplication of these two resistances. Okay, so now here we have 6 into 2 upon 4 plus 2 plus 6, right? So that comes out to be 12 by 12, which is equal to 1 ohm. So R2 becomes 1 ohm. Similarly, we will calculate R3, which comes out to be 6 into 4 upon 12, which is 24 by 12, comes out to be 2 ohms. Fine. So this resistance is 2 ohms. So we have calculated all the resistances. Okay. Now what I'll do is I'll replace this delta with its equivalent, okay, star connection. So how to do that? First 2 ohm resistor as it was, then you have 0.67, then you have 2 ohms, this is 1 ohm, this is 0.67 ohms, 2 ohms, and the remaining circuit as it was earlier. So this is 2, this was 6 and this was 7, right? And even this was 2 ohms. Okay, fine. Correct? This is clear? Now let us closely watch these two resistances. How are they connected? So I'll draw these two resistance separately here, and then I will understand what is the connection. So if this is 2 and this is 6, Now I got it that these two are actually in series, which makes it to be 8 ohms, right? Correct? Similarly, I will talk about now 1 and 7. Again, they are in series. So here you have series connection. So again, I will draw the new circuit. So this is 2. This we calculated to be 8. This was 0.67 and this was 2. Now if we talk about 8 ohms and 8 ohms, again they are in parallel, and what is the effective resistance of two 8 ohms connected together? It would be 8 into 8 upon 8 plus 8, which comes out to be 64 upon 16. So finally 4 ohms. Correct? So what I'll do is I'll replace this part. So now I have a 2 ohm resistor. I have 0.67 and a 4 ohms. So this is 0.67 ohms, and this resistance comes out to be 4. Okay. Now what is the final connection? All the resistances are connected in series. So what will be the total resistance between points 1 and 2? It is 2 plus 0.67. It is 0.67 plus 4 plus 2. Okay. So that comes out to be 8.67 ohms. Fine. So this is our final answer. I hope you understood this. Let us go to the next example. Okay. Now this seems to be slightly complicated, but actually it is not. Now what we are going to do is we are going to convert. Yes. Do you feel that first we should convert this star connection into delta connection? We can't do that. I'll tell you why. Because they have asked us to calculate the resistance between point 1 and 2, right? So I cannot do anything with a resistor which falls between these 2 points. So actually I cannot do anything with the internal star connection. Fine. But if I look closely in the circuit, I understand that there is a delta connection also. Fine. Which does not involve anything which is there between points 1 and 2. And this delta connection is this one. So what I can do is I can convert this into star. Exactly. So how are we going to do that? So first let us understand that. And see, all the resistances are of same value, isn't it? So all the resistances are of the value 4 ohms. So we can calculate the equivalent resistance only one, and all other resistances will be the same. Fine. So this we will convert into star. Fine. Let me represent this by R, because all other values will again be R. So now we will calculate what exactly is this R. So this R will be what? Multiplication of the other two branch resistances. Now this is going to be the same. So it is going to be 4 into 4 upon the sum of all resistances, which is 4 plus 4 plus 4. So that comes out to be 16 upon 12. So that comes out to be 4 by 3 ohms. Okay. It means all the resistances which we represented by R are of the value 4 by 3 ohms. Fine. So now let us change this delta connection and let us see how my new circuit looks like. So I will draw the remaining circuit as it was earlier. Fine. And this resistance we cannot touch. The remaining resistance will be like this. Yes. Fine. So this was 2, 2, correct? This was 4, and these 3, they are 4 by 3, 4 by 3, 4 by 3. Now this becomes a bit simple now. Now we know that 4 by 3 and 2 ohms, this and this, 4 by 3 and 2 ohms are in series. So let us calculate what will be the effective resistance. It will be 2 plus 4 by 3. So LCM is taken to be 3. So it becomes 6 plus 4. That comes out to be 10 by 3. Okay, so series resistance comes out to be 10 by 3 ohms. The same is applicable for these two as well. Fine. So I'll just simplify it and I'll show it to you. How do they look like? It means that this 2 and this 4 by 3 can be replaced by a single resistance of value 10 by 3. Fine. Now we will draw the new equivalent circuit. I will not erase everything so that it is available for us for the reference purpose. Okay, so we have a 4 ohm resistor which was connected between point 1 and 2. We are not doing anything with that. After this point, we have another resistance which was of the value 4 by 3. And then you have a resistor of value 10 by 3 here, of course ohms. And here one more resistor is there of value 10 by 3 ohms. Fine. So this is how we simplified it. Now you tell me what is the connection of this and this. These two resistances are in parallel, correct? And how to calculate the equivalent resistance? Equivalent resistance will be 10 by 3 into 10 by 3. This is 10 upon 10 by 3 plus 10 by 3. Right? So that makes it 100 by 9 upon 20 by 3. So that comes out to be 5 by 3 ohms. Okay, so my new circuit would be this. Fine. And this resistance is of the value 5 by 3 ohms. Now the next step is very important. Now it seems that the resistor 4 ohms and 4 by 3 are in parallel, but actually they are not. Because remember, we have to calculate the resistance between points 1 and 2. So as I told you before, we are not supposed to do anything with this point. Okay? it means that actually 4 and 4 by 3 look, it appears as if they are in series, but actually they are not. Fine. But then if you talk about 4 by 3 and 5 by 3 resistances, if you just forget, I'll do one thing, I'll erase the remaining thing and I'll show it to you. Fine. As of now, you have to forget the resistance which is connected between point number 1 and point number 2, because we are not supposed to touch it. Okay. So what we will do is, we will only draw other two resistances and let us see what is the connection. Now you tell me what is the connection. So the two ends are not connected, only one end is connected together. It means they are in series. So this 5 by 3 and 4 by 3 are actually in series connection. Correct? Yes. So what will be the total resistance in this case? What will be the total resistance? Series combination, you have to add it. So it is 5 by 3 plus 4 by 3, which comes out to be 9 by 3. Ultimately, it is 3 ohms. Fine. So my new connection would be this 3 ohms and this right? Correct? Yes. I have to change it. Sorry. Now the new connection is, wait a minute. Yes, this was point number 1, this was point number 2, and the new resistance is actually placed here. Yes. So that comes out to be 3 and this is 4. So basically these two resistances are in parallel now. So what is the total resistance? The total resistance will be the parallel combination. So that comes out to be 4 into 3 upon 4 plus 3, which is 12 by 7. Okay, and that comes out to be 1.71 ohms. Okay, so here I can say that the resistance between point 1 and 2, rather I will erase all. So my final resistance between point 1 and 2 comes out to be of value 1.7 ohms. Understood? Okay. Now let us go to the next example. Now this example is a homework for you. Fine. So you can see that I have given a hint as well. Fine. So this hint is that we need to convert this delta connection into its corresponding star connection. And again you can see that all resistances are of the same value, and that is of 12 ohms, isn't it? So once we calculate one resistance, we'll be able to replace all other values. So let us understand what will be the star equivalent resistance. So how to calculate that? If this is R1, what will be R1? R1 will be multiplication of the two resistances divided by the sum. So it is, that comes out to be 4 ohms. So this resistance is actually a 4 ohms. And even this is 4 ohms and this is 4 ohms. Correct? So this is how we are going to solve it. Fine? So what, see, this is how it looks like. Okay, so this was 4 and this is given as 3. So now 3 and 4 are in series. Similarly, this is 4, this is 3. Again, these two are in series. So if I draw the connection here for your reference purpose, this is 6, this is 6. Okay. What will be the next resistance? Now here you have 7. Again you have 7. And here one resistance of what value? 4. So this is 7 and this is 7. But here again one more connection is there like this. So it means that what about these two connections? They appear to be in series, but actually they are not, because here they are connected and another end is connected with the help of this connection. So actually the connection of 7 and 7 are parallel. Fine. Similarly, if you talk about two 6 ohm resistances, again if you see they are connected here and another end is again connected with the help of this path. Fine. So see, this is the connection and another connection is with the help of this path. So if you talk about 6 ohms, they are also in parallel. So I have given you enough hints to solve this circuit. Fine. I hope you will solve this and you will get the final answer. Let me tell you the final answer. The final answer, which is the resistance between point 1 and 2, comes out to be, the final answer, which is resistance between 1 and 2, comes out to be 10.5 ohms. So you can check whether your answer comes the same or not. We shall meet in the next lecture. Thank you.